A rare mosquito-borne illness strikes again.
Officials are on high alert for Eastern equine encephalitis virus.
Eastern equine encephalitis.
Eastern equine encephalitis, or EEE.
A rare mosquito-borne illness that's turned deadly.
Mortality rate of 30%.
At least 3 states reporting possible human infections.
5 people have died.
That's now 7 deaths.
And 9 people have died.
11 of them have died.
The worst outbreak of Eastern equine encephalitis in a decade.
Scary.
Yeah.
So for my birthday last year, we didn't do much to celebrate. My husband and I went camping up in upstate New York. We paid a guy that we met online $30 to let us pitch a tent on his land, which sounds super sketchy now that I say it. But there's one not so great part, which is that I got completely eaten alive by mosquitoes. Itchiness aside, I was dumb to get bitten for a more serious reason, which is that here in the eastern United States, mosquitoes can spread Eastern equine encephalitis virus, also known as EEE. As the name suggests, Eastern equine encephalitis was first found in horses, where it causes swelling of the brain. But unfortunately for us humans, it's not just a disease of horses. So the scary thing about Eastern equine is that of the people that get sick, about a third of them die. And about half of the ones that survive are left with neurological symptoms. But anyway, to distract myself from the sundry and myriad infectious disease-based threats on my life nowadays, I decided to make this video. So I mentioned that the disease was first found in horses, hence the equine part of the name. Equine? 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 Equine. 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 Apparently it's equine in the U.S. So our story begins in 1831 when 75 horses mysteriously died in Massachusetts. So the first human case was recorded a century later in 1933 when 30 kids in the eastern United States died, near to where horses were also sick and died. So even early on, there were some clues about how this pathogen operated. So one of the clues was that oftentimes at the same farm, only some of the horses died, and often the farmer wasn't sick at all. This suggests that the disease wasn't spread by direct horse-to-horse or horse-to-farmer contact. It sounds kind of dirty. Instead, the pattern would be consistent with a biting insect spreading the disease. And sure enough, eventually they found Eastern equine encephalitis virus in a mosquito. So another question was, where did this virus come from, and where was it hiding between outbreaks? One clue was that the virus levels in humans and horses were too low for them to be anything but a dead end for the virus. Scientists realized there must be some other species serving as the reservoir for the virus. And considering how far-flung the outbreaks were up and down the eastern seaboard, whatever species it was would have to be very widespread. Although it did seem to be that outbreaks were clustered around like marshy areas. So for instance, in 1933 and 1934, the virus showed up at the same time in the northern neck of Virginia and the eastern shore. Those spots are on opposite sides of the Chesapeake Bay, even though they're only about 20 or 25 miles apart as the crow flies. To walk all the way around would be a distance of hundreds of miles. So speaking of crows, birds are very widespread. So scientists began to speculate that the virus could be circulating in birds as a reservoir host, with spillover occasionally to humans and horses. It wasn't until 1950 that scientists confirmed this theory by finding the virus in a wild bird in a Louisiana swamp with no sick horses or people nearby. So thanks to these and later scientific sleuths, we now have a pretty good idea of the disease ecology of the virus, or how the host and disease and other factors interact in the context of their environment and evolution. So here's a review from last year with a good summary of what we know. Oh hey, I know that guy. So typically EEE hangs out in this bird-mosquito cycle, hitching a ride on mosquitoes to hop from bird to bird in the forested wetlands of the eastern United States. So these bird mosquitoes, known as the primary vectors, don't bite humans or horses, so the virus stays put in the birds. So for the disease to make the jump from birds to humans or horses, you need a mosquito species that feeds on both birds and mammals. These mosquito species are called bridge vectors because they bridge the gap between the two. So to recap, there are 2 kinds of mosquitoes. Primary vectors that feed just on birds, and bridge vectors that feed on people too. I'd heard tell of a place with loads of these primary vectors, these bird mosquitoes, and it happened to be really close to my house, so I figured I might try and find some. So a few weeks back, on a cold December Saturday, I dragged my long-suffering husband along for a hike to try and find us some bird mosquitoes responsible for Eastern equine encephalitis virus. The one I wanted to find was Culiseta melanura, the black-tailed mosquito. It's also known as a cedar swamp mosquito, so I went to a cedar swamp.
Artsy shot right there.
It's a really weird mosquito. So usually mosquitoes in the Northeast survive the winter as eggs. Some other species have females that hibernate through the winter, usually underground. But the black-tailed mosquito overwinters not as eggs or as adults, but as aquatic larvae in freshwater swamps and bogs. So underneath the buttress roots of trees, the black-tailed mosquito larvae develop super slowly in this cool acidic water. So these underground crypts can be hard to get to if you're bigger than a mosquito. So I brought this bilge pump, which is a thing that boaters use to bail out their boats, and I sucked up water from these underground layers to look for mosquitoes. So after a few attempts, I managed to find one larva. And then I quit because it was really cold. So these primary vector mosquitoes feed on just birds, and they let the virus spread and build up over the summer months after the birds have migrated into the area. In order for the virus to make the jump to horses or humans, you need mosquito species that feed on the blood of both birds and mammals. So it's winter now, but back in August, I set as my goal to catch one of these bridge vector mosquitoes that bite both people and birds. I thought it was going to be very easy, and it turned out not to be. This is mostly because I stubbornly refused to buy a mosquito trap, and instead I just insisted on using a MacGyvered trap that really didn't work very well. So the trap I made was very simple. I made it essentially with trash I had laying around my house. It was a box with an opening that was easier to get into than out, and a tube to let out a stream of carbon dioxide. Carbon dioxide is a great mosquito attractant because it's what female mosquitoes use to find animals, including humans. The first traps use a mixture of yeast and sugar to make CO2, to trick the mosquitoes into thinking that the trap was a person. I hung them in my backyard, and I failed to catch any mosquitoes. I tried again on the edge of some guy's farm up near New Paltz. Dogged persistence in the face of shitty odds, and I failed to catch any mosquitoes. I tried again on the super nice guy's dairy farm outside of Callicoon, and I failed to catch any mosquitoes. Anyway, here is Christina from 3 months ago to tell you about her ultimate success. So after failing 3 times to catch mosquitoes here in New York State, I decided to have one last attempt. So I headed south to my natal land of Pennsylvania, where the landowner agreed to let me catch mosquitoes on her property in exchange for hoagies from Wawa, which is the most Philadelphia of currencies. And there are definitely mosquitoes there. I got bit, including this once on the forehead, and at long last, I was successful. Kind of. I only have one species to show for my efforts, which is not that many, but it's also infinitely more than nothing, so I'm going to count it as a win. So I have this mosquito right there. It's going to be hard for you to see it. Don't look at my face. Look at the mosquito. So you can see it on my pasty white skin. So I'm not a real entomologist, so I'm not 100% certain of my identification. It looks to be the infamous Asian tiger mosquito, scientific name Aedes albopictus. It's originally from Southeast Asia, but it's invasive in the United States, which sucks because it transmits a lot of diseases, including yellow fever, dengue, chikungunya, and it had also been found infected with our friend Eastern equine encephalitis virus. Thanks, Christina, from 3 months ago. I was so young then. So I'm very happy we managed to find the 2 villains of this story, the primary vector that feeds on the birds, and the bridge vector that allows the disease to jump from birds to people or horses. One of the reasons I love vector-borne diseases, maybe I shouldn't say I love a class of diseases. One of the reasons I love to study vector-borne diseases is how ecologically complex they are. You have these interactions between birds and mosquitoes and trees and people and horses and rainfall that all come together to determine whether or not a virus jumps the species border to cause disease in a new host. There's this neat story from Massachusetts that illustrates this ecological complexity. So remember how I said there was a big horse die-off in 1830-something and then not much to talk about until a bunch of kids died about 100 years later? It seems like this virus kind of went on hiatus for a century before coming back. There's this very cool paper that speculates why this could be. So those primary vector species, like the ones I sucked up with the pump, they live in white cedar or red maple swamps. So in the early 1800s, European colonists destroyed the great white cedar swamps of New England. They used the wood for shingles or barrels or whatever, and they drained the swamps or converted them to cranberry bogs. Over the next century, the swamps were reestablished, this time with more red maple trees. So by the middle of the 20th century, helped along by conservation efforts to restore wetlands, those trees had matured enough to put down buttresses, providing a perfect place for the Culoceta mosquito to lay eggs and a perfect place for birds to roost. Such birds include the American robin, which does very well in suburbia nowadays. So after about a century of hiatus, the swamps returned, the trees returned, the birds returned, the mosquitoes returned, and along with all of them came the return of the Eastern equine encephalitis virus. All of these pieces had to be in place for the virus to come back. So all these moving pieces make it very hard to predict how bad a year is going to be. We don't know why 2019 was such a bad year with about 4 times as many cases as typical. So luckily, 2020 saw a return to normalcy, at least in this one very narrow aspect. Just about everything else about 2020 was not normal. Folks are still worried about the possibility of climate change making perfect conditions for spillover and increasing rates of eastern equine encephalitis virus. Time will tell if that's the case. Luckily, as scary as eastern equine encephalitis is, the odds that you will get it are crazy low. Take the typical steps to avoid mosquitoes and try to worry about more pressing matters. So hopefully you now know a bit more about vector-borne disease biology and spillover. I'm very proud I managed to show you the bird mosquito species pulled out of a hole below a tree in a freezing swamp, as well as the bridge vector species that allows the disease to jump from birds to people. So trying to catch mosquitoes was a very humbling experience. So I also hope it underscores the impressiveness of the work that field entomologists and disease ecologists do to keep us all safe. So I have some other videos in the works. Let me know if you enjoyed this one. I've had a lot of fun making it. It's nothing like talking about a deadly disease to take one's mind off the current pandemic. And then the bridge vectors that allow the disease, and the bridge vector that lets the disease make the switch from birds. I can't say the word disease, turns out. Disease.